Okay, let's get started. Good afternoon, and thank you for tuning in to our webinar. We appreciate you taking the time out of your busy day to join us to discuss the smart manufacturing journey, best practices, successes, and lessons learned. My name is Richard Phillips, and I will be one of the presenters today. More on that in a few slides. This webinar is the first of a series of virtual events that are being held in place of our traditional in-person smart manufacturing deep dive event. Our third deep dive event was planned for this year, but is being postponed until next year due to the COVID pandemic. In the meantime, we will use these virtual events to share, discuss, and collaborate. Please participate by submitting any comments or questions using the Q&A function provided. This first webinar will provide a primer on our best practices for executing smart manufacturing projects, in addition to an overview of 4 key case studies. Future webinars will provide a deeper dive into specific case studies. We'll announce the details of our next webinar at the end of this presentation. As an introduction to your host today, Polytron has delivered thousands of manufacturing solutions over the past 35 years that have helped its clients improve productivity, meet their business challenges, and drive profitability. Polytron's smart manufacturing team specializes in helping manufacturers develop and implement their digital transformation strategies and roadmaps with a focus on delivering incremental, measurable business value along the way. In addition, Polytron has expertise in designing and delivering solutions in automation, industrial networks and cybersecurity, machine safety, and process and packaging systems. Polytron was named Control Engineering's 2019 System Integrator of the Year and is certified by the CSIA, which is the Control Systems Integrators Association. Shown on the slide are some of our key customers and technology partners. Your presenters today from Polytron are Brandon Brock, who is a Clemson graduate with bachelor and master degrees in computer engineering, and for the past 15 years has developed and deployed many different IT and database solutions for Polytron's manufacturing customers across several verticals. Jim Flagg is a graduate from Georgia Tech with dual bachelor degrees in electrical and mechanical engineering. Jim has 25 plus years of experience, the last 15 spent at Polytron, helping architect and lead teams in implementing manufacturing intelligence, MES, MOM, IIoT, and smart manufacturing solutions. And myself, Richard Phillips, I'm a graduate from Auburn University with bachelor and master degrees in electrical engineering and have been with Polytron for 20 plus years in multiple roles and now lead our smart manufacturing solutions group. Before we start, a little on Polytron's approach, perspective, and why we're doing this webinar. Through smart manufacturing deep dive events mentioned earlier and workshops conducted over the past few years at several conferences, we have extensively covered some of the basics of Industry 4.0, drivers, benefits, and issues such as PLC Purgatory. So we're going to assume that you're already up to speed on those items. Our objective here is to share Polytron's collective perspective, experiences and case studies, and lessons that we have learned from many implementations. We fully acknowledge that others have valuable experiences and learnings, and we are always welcoming to learn about those as well. We don't sell specific hardware or software. We feel the market is full of options. We want to help guide customers on how to be successful and are passionate about doing that. As a consultant and systems integrator, we are fortunate to be able to deploy multiple different solutions for many different manufacturers across many different verticals and find that experience worth sharing. Like continuous improvement and learning in general, it's a journey. It's not a once and done, but it's important to be successful in the first stages of this journey, as that will feed energy and funding for future phases. And speaking of being successful in the first stages of the journey, here are the key steps we've identified for a successful smart manufacturing journey. Business drivers first. A business strategy has to primarily deliver business results. For manufacturing, these are typically lower cost, higher throughput, improved quality, meeting customer orders, improved compliance, lower risk, etc. We still see instances of projects focused on implementing a desired technology without an understanding of what problem it is going to solve. To help ensure early success for Smart Manufacturing Initiative, we recommend finding the highest value opportunity for the first phase of implementation. That is, what can technology help solve for the lowest cost to deliver the highest benefit? Once the business driver is understood, it's important to develop the detailed requirements for the project and ensure all stakeholders understand what will be delivered and are in alignment, or as they say, are on the bus. Don't forget the importance of ensuring that people understand how the project will benefit them personally. You'll see an example of how important this is in our first case study. Equally important is to optimize your process and implement change management to leverage the technology being implemented. In the same way that you don't want to automate a bad process, you don't want to provide tools that are not going to ultimately be used. Technology stack. We'll talk more about this in a few slides. It's critical to understand your short-term and long-term needs so that you select as few technology solutions as possible to meet all of your needs. In other words, you don't want to find a point solution for every problem you're trying to solve and then end up with many different silos of data, thus making it very difficult and costly to contextualize your information across the many different silos. If there are platforms, and there are, that can meet most or all of your requirements without adding another piece of software, then that should be carefully considered. This contextualization of the data is one of the key benefits of digital transformation through use of solutions as simple as dashboards to give you insights, scoreboards, reporting, and alerts, or through more advanced solutions such as machine learning and algorithmic production scheduling. Roadmap development will involve identifying which solutions you will deploy first and where. Once the ROI is proven, the business will want to accelerate deployment. The longer you delay, the less time you're benefiting from the savings generated. If the ROI is 3 months or less, for example, like you'll see in the first case study, then the project savings can pay for the project every 3 months. So waiting is costing you money. We still see examples of multiple solutions being rolled out in parallel within an organization, but most businesses can only handle so much change at one time. As discussed, change management is a critical step as well. Heat map for a pilot. So given that your initiative is more likely to be funded and move forward based on the level of success that you're going to show on the first pilot, you want to do everything you can do to help make sure it is successful. This includes items such as make sure you select the right line in the right area for the pilot so that it shows the most improvement and you have the highest likelihood of showing the most improvement. Picking the right solution and technology is critical, and ensuring that the people involved in the pilot are going to want to make the project a success as well and are receptive to the technology. Steps 8, 9, and 10 are natural progressions of what we already discussed. Ultimately, we're looking to make business smarter through smarter manufacturing. We want to solve business problems and show a return for the investment made to fuel future phases. We'll see a clear example of this in our first case study presented. So this slide gives you an idea of some of the technologies associated and associated solutions that we're discussing. A few items worth highlighting. This modern manufacturing operations management platforms discussed. It's going to be covered in detail in a future slide. We find that most manufacturing facilities need an MOM platform to avoid the data silos created by point solutions, as we discussed earlier. With IIoT and cloud-based solutions, we see those making a lot of sense outside of a manufacturing facility where the infrastructure does not exist, but there are exceptions to that as well. Mesh-enabled and wireless smart sensors have allowed manufacturers without a network infrastructure or with older assets that don't have data connectivity options to start collecting data at a small scale from key points in their manufacturing. A few data points allow you to have great insights. Things as simple as what is my OEE, or doing condition-based monitoring using a few wireless vibration sensors. We'll discuss the RFID on a few of the case studies presented today. We see a resurgence of RFID given the lower cost of tags and the greater functionality provided by fixed and handheld readers. If you're familiar with the Gartner hype cycle, this is an example where the excitement came many years before a cost-effective, viable solution was readily available. So we're definitely seeing a resurgence of that in many different applications, from traceability, inventory management, on your dock doors, seeing what gets shipped out or what gets received and so forth. One more I'll mention is blockchain. We see a big opportunity specifically for machine OEMs who are looking to collect data from their machines running at their different customer sites. Benefits include collecting and sharing of optimal run settings and predictive maintenance to identify failures before they occur so that the part can be shipped to the customer and then the customer alerted before the failure occurs. IoT connectivity and blockchain make this affordable and feasible. So if you're a machine OEM and are interested, reach out to us and we can set up a call to discuss this specifically and provide a demo of the blockchain solution from one of our technology partners. I will now hand it over to Brandon to share our first key case study.
All right, thank you, Richard. The client for this first case study is a fast-growing bottled tea company that needed to rapidly increase their production due to high demand. In order to achieve this goal, they needed to squeeze every bit of efficiency out of their existing equipment in order to buy time for further expansion. They faced a number of challenges that they would need to overcome. The manual recording of data was unreliable at best and prone to error. There are no systems for capturing real-time data, so they couldn't act upon that quickly. The organization had no visibility into how manufacturing was performing in real time, and disparate systems allowed limited or no integration to see data from multiple areas at once. The goals of this project were, number one, to increase production. They needed a system to provide real-time data that allowed targeted improvements that would provide the highest value. Next, they wanted organizational visibility. They needed a system and a platform that would allow users across the organization to get real-time data and make quick decisions based on reliable insights. And then they wanted that single platform to integrate data from multiple systems and legacy applications into a single trusted platform. So this solution can be summarized by looking at each of its primary parts. The system provided performance management for 3 filling lines. The data from each of these lines was automatically collected from the PLCs through OPC. This data was then used to calculate OEE and other KPIs for each line and piece of equipment. We provided integration with their ERP system in order to download things like production schedules automatically. This prevented errors that typically occur due to duplicating entry into separate systems. We also made use of IIoT smart devices in areas where there were no PLCs readily available to collect data. This allowed us to gather basic data such as bottle counts or line stoppages. We also used a historian to capture process parameters and perform data analysis. This allowed some real-time statistical displays such as average bottles per minute. These real-time displays were then placed on scoreboards throughout the plant. Each one displayed real-time data that was related specifically to that area of the plant and encouraged operator engagement through improvement of their own numbers. We implemented a maintenance management system to replace an existing legacy system, and this allowed new features such as real-time maintenance requests by operators and live status tracking by maintenance supervisors. This also included a system for tracking spare parts and issuing POs to vendors. With the success of the first plant, we also rolled out the same solution to the second facility with all of the previous functionality included from the start. The slide here, if you look at the bottom, shows one of the scoreboards for the box packer area. So operators could look up and see at a glance what their current numbers were. And then the image to the right shows some of the statistics that were available to the maintenance supervisors, including line failures, upcoming scheduled work orders, and high priority requests. Now let's talk about the results. Probably the most important bullet here is that the initial project cost was recouped in 3 months, as Richard referred to earlier. They saw a significant increase in their OEE from the time that the system was initially rolled out. This increase led to a substantial increase in the amount of product that they could get shipped out without any significant changes in assets. They were able to offer incentives to their operators to improve and maintain high OEE and therefore high production numbers. And the improvement in line efficiency meant that less scrap was created due to long downtimes. And then finally, because they were able to get so much more production out of their existing equipment, they were able to put off the construction of their new facility by 18 months. A few additional dashboards shown here to the right. At the top, you can see a dashboard from the maintenance management solution. These show you things like work order statistics and labor hours by priority. And then below that, you can see the current status of each line. At a glance, the plant personnel can see what's being run, how fast it's running, and their OEE broken down by day and shift. We're also heavily engaged in with this client on a continuous basis, and together we've outlined a number of future phases. They would like to expand their system to integrate all assets not currently in the system. These assets are outside of the typical line, but they could also be well served by knowing their KPIs. They're also looking to replace their existing WMS system and include it in their MOM platform. This includes more integration with their ERP to better track inventory. They're also looking to replace their existing QMS system with a real-time statistical alert system. And they're looking to enhance their current scheduling system with algorithmic scheduling to minimize things like changeover and get even more efficiency out of their lines. And then they're looking at various uses for a visual workflow system that will allow them to create even more streamlined processes for things such as paperwork and quality checks. Oh, and one additional thing worth noting is that we're implementing over the next month an enhancement to their WMS functionality where we installed a barcode scanner to read each pallet going into their cooler warehouse. They're currently getting a few no reads from the barcode scanner, which they found were due to misapplied labels and stretch wrap. So to confirm this, we're adding an IP camera to capture a picture of each no read pallet as it passes. The IP camera will then be integrated into the MOM platform, and so reporting of the no reads and associated picture are all easily accessible and correlated in a single report. At the end of this webinar, we're going to provide you with a registration link to register for our next webinar, which will be focused entirely on the details of this case study. Our customer will be co-presenting this with us, and it's currently scheduled for September 30th from 2 to 3 p.m. Eastern Time. I'll now hand it over to Richard to share what we've learned as key features to look out for when you're selecting an MOM platform.
Thank you, Brandon. Let's now deep dive into some of the specifics when selecting a manufacturing operations management platform. Single platform. As discussed previously, there's tremendous value in simplifying your technology stack when possible. Simpler maintenance, less licensing, fewer data silos, fewer user interfaces, less integration and complexity, less training, lower cost of deployment are some of the synergies. But there's also synergies in the software infrastructure itself in terms of sharing dashboards, reports, data entry, alerts, and so forth. A quick warning on this item. This does not mean that you should use your ERP system for your MOM functionality. We're talking about grouping MOM functions as possible. Part of the effectiveness of a modern MOM solution is leveraging the out-of-the-box functionality that's already developed by the MOM vendor. MOM vendors develop their out-of-the-box based on best practices collected from many of their different implementations. So consider starting with the out-of-the-box to keep the initial cost of deployment low, which will help increase your ROI for the first phase. Then, given that every business has specific requirements, the platform needs to be extensible to allow development of business-specific metrics and other requirements, in addition to allowing for easier integration into other systems. Make sure the platform is built on modern technology to leverage mobility, enhance security, easier integration. Be cautious of 20 to 30-year-old platforms built from several point solutions put together with a modern front end. This is different than a 20 to 30-year-old solution that was rewritten on a modern platform. The latter is what you're looking for. Make sure to vet out the case studies provided by the MOM vendor. How old are the case studies? Was the ROI achieved? Was the solution accepted by operations? Is it sustainable? Are they expanding the solution? And is the team excited about using the system? And then lastly, when you select an MOM platform for your journey, you're starting a partnership with the MOM vendor. Make sure they are someone you want a long-term relationship with. Make sure they're innovative and have a track record of releasing new functionality, such as digital workflow, algorithmic production scheduling, to name a few, and other advanced functions similar to that. All right, next up is Jim Flagg is going to discuss our second key case study.
Thank you, Richard. This case study is for a Fortune 200 food and beverage company that wanted to produce a new ultra premium juice, or UPJ, product they had never made before. The ultra premium juices are more expensive than traditional juices due to their high nutritional content. This is a result of using fresh from the farm ingredients and using high pressure pasteurization rather than the traditional heat pasteurization. Due to the high pH value of vegetable ingredients, high pressure pasteurization process, and containing no preservatives, this new UPJ product has a lot of food safety issues and requirements. Ingredients, whipped product, and finished products all have very strict expiration, temperature, and handling requirements. The high pressure pasteurization process, or HPP, requires the bottled product to be exposed to extremely high pressures of around 80,000 psi. This required shipping the bottled product to a different facility and running it through specialized HPP equipment within 24 hours from when a batch is first mixed. Monitoring the temperature, checking the expiration time, and recording tracking information became a complex process. The company decided to use full electronic monitoring of the food safety parameters and tracking of ingredients, whipped, and finished product for quality and recall purposes. A combination of barcode, RFID tags, Bluetooth technology, along with manufacturing operations management software, were chosen to track these critical requirements. This system architecture diagram on the right gives you an overview of how the MOM software tied everything together and allowed an interface to their ERP system. As you can see from the product flow diagram, there are many steps required to make UPJ product. Each of these steps have critical data recording and traceability requirements. It all starts with the farms that provide the vegetable ingredients. this diagram only shows one in green in the upper left-hand corner, but the supply chain included multiple vegetable providers. Each of these vegetable producers are equipped with RFID label printers that encode the grower, the lot, and the expiration information into every box of fresh vegetables. An automated RFID reader system at the main production facility in red would verify the freshness of every vegetable box and track lot information as the vegetables are consumed. The pre-weighing of ingredients and multiple vessels used to prepare and mix the ingredients added to the complexity of the traceability requirements. Eventually, the juice ends up in a finished bottle at the main production facility, but they are still not ready to drink. They need to be pasteurized. So these whip bottles are shipped to the co-packer facility in yellow. Here again, lot numbers and whip expiration dates are validated using RFID tags. Finally, the bottles are run through an HPP process and are packaged in finished cases for shipment to the warehouse. This requires more data recording and tracing, including interface to their WMS system. And even when the product reaches the warehouse shelves, the data recording is not complete. The system must also verify the finished product is maintained at the proper temperatures within the warehouse. As you can hopefully see, this UPJ product required a lot of data recording and correlation of data. Using electronic MOM solution to record this data provided many advantages, as you can see on the left. If the company received a consumer complaint about a specific bottle of juice from a store, all the information to check batch process parameters, ingredients, lot information, and processing times could be easily retrieved from the MOM system database. In the same way, if a vegetable supplier indicated there was a quality or safety issue with one of the vegetables, the system could show all the finished product bottles that consume that same lot of raw ingredients. From this slide, you can see many of the other advantages that an electronic tracking system provided. For this customer, one of the nicest features was that all the recorded data could be monitored and viewed from any location with just a web browser through one internal website rather than sorting through filing cabinets of paperwork. It did not matter if you were responsible for raw ingredients receiving and inventory, needed to check batch process quality information, were at the co-packer and wanted to know what product is headed your way, or at a warehouse and checking on finished cases. You could go to one internal website to find all your information. And now over to Brandon to present our third case study for a silo monitoring system.
All right, thanks, Jim. The client for this third study is a global manufacturer of food packaging solutions. They were interested in improving the existing raw materials inventory and management system for raw materials stored within silos. The legacy system utilized plumb bob level sensors in conjunction with the vendor's proprietary software. The client wanted greater visibility for supervisors and operators, as well as to collect relevant information in a historical database for report generation and compliance needs. The existing system exhibited several challenges. Operators manually checked the level using the plumb bob sensors located near each silo. This software did not report any levels back to any outside systems, and the manual nature of this limited the number of checks that were done per day, so there were no real-time updates. Because there were no external monitoring of levels, there were also no alerts generated for things such as low level. And receipt of raw materials was done through paper forms. These forms did not allow error checking to catch things such as unloading into the incorrect silo. Errors such as these were very costly for the company and were not rare. The goals of the project were first to go paperless. Currently, if they had to recall a rail car, for example, they would have to go through a load of paperwork to manually track the lineage. If they were to go paperless, they would be able to track that much easier And then mobile access and future functionality that a digital infrastructure could provide was also of interest to them. They also wanted more accountability. They wanted to know who was working in the system and executing unloads, transfers, etc. And then they wanted a better defined overall workflow. The digital solution would give people the ability to execute documented workflows instead of relying on one person to do it correctly. So the new silo monitoring system utilized existing level sensor technology and interfaced using Modbus RTU and other hardware interfaces. The gateway communicates to the Polytron silo monitor application via plant Ethernet, and installation could be done on a standalone server or a VM. Operator access to the system via mobile tablets using wireless access or at the unload stations or from areas inside the plant. Supervisors had continuous visibility via 48-inch dashboards, as well as access from any desktop computer around the plant. They had 10 concurrent user licenses available, and the data was stored in a SQL database and was available for management queries and reports. So let's take a look at a few pieces of the solution. On the slide here, you'll see the first piece is the silo overview screen. This is a dashboard that provides real-time visibility for all plant silo inventory. Each tile here represents a silo and contains important information such as the current material type, the pounds of product, the current status, and even has a color indicator that shows what the current volume is and if there are any alerts such as low volume. Another piece is the mapping screen for the bins. This allowed the operator to link the silo to specific bins for material transfer. Note that this is a user-initiated function in the current installation, but it does represent the physical configuration in the plant. This function was used to provide a tracking record for the assignment of materials to specific bins and extruder lines. This was very important in the event that a detailed tracing was needed, such as a recall. The next piece is the trail and rail car unloading screen. Each unloading location is represented by a tile on this screen. So for each rail location, there's also a column for each compartment, and that would be the bottom part of the screen there. The current status of each location is shown on the tile, including whether it's in use using color coding, the material that is being unloaded, the target silo that is being filled, and which pump system is being used, if any. Operators can check on a tile to fill, or can click on a tile to fill out the unload form or to mark an unload form that is in process as completed. As part of this form, there are also several rules that provide error checking. These rules assist the operator by avoiding accidental material mixing and also showing them which pump systems are currently available to use. And to conclude, let's take a look at the results. The digital platform has demonstrated value to the plant management and users since installation and has enhanced daily operations as well as access for compliance needs. The solution also addresses the need for reporting. All transactions and user interactions are captured in a SQL database and are available for management for reporting functions, and information is available in filterable reports from any system-wide computer. These reports can also be printed or exported to standard formats such as Excel or PDF. And the client has also expressed interest in future enhancements to this system. They may want to do things such as include photo capture of bill of ladings and certificate of authenticities for digital record keeping, add error checking between bill of lading amounts and actual quantities unloaded, and then additional tracking of railcar times at the site to avoid fees. All right, now Jim will present our fourth case study on an RFID inventory management solution we developed for a filter manufacturer.
Jim, you're still on mute.
Sorry about that. This case study is for a company that is a global leader in the field of large industrial filters. These filters are similar to the ones you might have to filter water in your kitchen, but are much larger. Most of them are used for reverse osmosis in large water treatment and desalination facilities. This company has been making filters for years and used barcode technology to track each individual serialized filter. Each filter is completely water tested. These actual test results are unique for each individual filter, so it isn't just a simple pass-fail type of test. The barcode process sometimes slowed them down and caused inefficiencies. They could see that they could cut cost and increase efficiency by using RFID technology and enhanced filter tracking. The two pictures on this slide show some examples where RFID could increase their efficiencies. The picture on the left shows filters coming out of a hot oven. It would be difficult and time-consuming to read each of the 16 filter barcodes with a handheld scanner, since the barcodes are placed in the center of the filters. But due to these difficulties in using barcodes, it was not worth the effort, so they lost traceability at this point. But fixed position RFID readers could read all 16 filters automatically at the same time. The picture on the right shows a typical view of the plant floor. The process of making filters is fairly labor intensive and requires a person to manually move the work in progress filters throughout the facility. At any one time, around 5,000 filters are scattered in various stages of WIP around the facility. Twice a year, they are required to stop production and have personnel manually scan each filter barcode in the complete facility for inventory purposes. This means manually separating every filter and making sure the barcode is positioned so it can be read with a handheld scanner. With an embedded RFID tag, the filter serial number could be quickly read without the manual separation and rotation of the filters. They also saw some potential for their end users to use the RFID for their own inventory purposes, since some of the large water treatment facilities would use tens of thousands of these filters. The filters could also include original test data, and the end user would easily be able to compare the current used filter performance to the original manufactured performance of that particular filter. We have already talked about some of the issues the plant had with barcode technology, and you can review them at the top of the slide. So I'll focus now on the benefits that the RFID technology had in increasing their efficiency and reducing their cost. RFID tags can be read from any angle. This was a big efficiency enabler. They could read straight through the filter to an RFID tag on the back side of the filter without worrying about orientation. RFID technology can read multiple tags at the same time. This significantly sped up their twice annual inventory process. And finally, water test data for each filter was saved to the user memory of their RFID tag, so it could be read by plant and warehouse personnel as well as by the end user. Even though two filters have the exact same part number, the variation in their actual performance is important to the end user. Also, RFID tags are not affected by abrasion, ultraviolet light, or other environmental conditions and will last the life of the filter. Shown in the top row of the images are the RFID reader equipment that was used on this project. This includes, from left to right, an RFID label printer, handheld RFID reader, fixed position RFID reader, and corresponding antenna. Shown in the bottom row of pictures are some examples of the custom handheld RFID reader screens that we used to interact with the tracking system. They allow the user to see the information stored in the RFID tags. The new RFID system delivered on all the plant's initial needs for increased efficiency and reduced costs. The biggest savings were in the plant-wide inventory reconciliation. The plant has been able to complete the inventory process in less than half the time of the previous barcode-based inventory system. A process that took from 6 to 24 hours to complete has now been completed in as little as 3 hours. Richard, if you can go to the next slide. After the initial installation of RFID system, additional projects have been implemented to expand the system for further cost savings, such as a robot application had to stop and rotate each filter through 360 degrees in order to allow a barcode reader to scan the serial number of a filter. By replacing the barcode reader with an RFID reader, the plant was able to cut valuable seconds off of the robot execution process. Somehow there were filters that were being lost between the manufacturing facility and the production warehouse. By installing more fixed readers at locations such as dock doors, they were able to track and eliminate these lost filters. And finally, the company is now looking at enabling extra features in the RFID tags to add functionality the end user will see as adding extra value to their filters. And with this, Richard, back to you.
Thank you, Jim. If you haven't yet, consider downloading the Smart Manufacturing Index that we provided a link for when you registered. It's proven to be a valuable exercise for folks who've attended our past workshops. Your current state for your people, process, and technology will help you better understand how you compare with other manufacturers in the key steps to move up in each category. Understanding and effectively addressing the people and process parts are critical to ensure that the technology solution is well received, effective, and delivers the expected results. All right, we hope you enjoyed the webinar. Please submit any questions that you have through the Q&A function in Zoom. We still have a little bit of time left, and we will get to those as they come in. First question, how does Polytron collect data from PLCs? That's a good question. Brandon, can you take this one?
Sure, Richard. Typically we do so by using an OPC server that may already exist in the plant, or if not, we'll install one. And then the MOM platforms typically act as an OPC client that can then read that those tag values. Now, as far as the PLC itself, Polytron provides a system tracking file, which will often be used to consolidate the data that we're specifically interested in into a number of specific data tags, and then we use those through the OPC server.
Perfect. Thank you, Brandon. All right, second question. We're looking at starting our digital transformation journey, but the cost of installing an Ethernet network and upgrading the PLCs has been an initial barrier. Any comments on how to get past this initial cost, at least for the first phase? Jim, how about if you take that one?
Sure. This is a common issue that some of our customers have, especially for a proof of concept or a pilot project where the project can't justify the full cost of upgrading your plant-wide network or upgrading PLCs and so forth. So this is where wireless technology that's coming of age now with IoT and some of those other things makes this much easier. So if you have some sensors that you need to scatter around your facility or whatever, rather than putting in new PLCs and a whole new network, you can wirelessly communicate to them either through Wi-Fi or other new technologies like Zigbee.
Perfect. Thank you, Jim. All right, third question. Is smart manufacturing mostly for larger companies that can afford it? All right, I will take this one. Not at all. That's the great thing about the cost effectiveness of these modern technologies we discussed. And therefore, really, one of the big momentum drivers for Industry 4.0 is that it is available for everybody. The first case study that we mentioned, as discussed, was for a company that has a single factory, family-owned company, single factory. But the agile phased implementation approach we're able to use, even though we used a technology platform that does a lot of different things, but we're able to start small, show the value. Within 3 months, we're able to show the ROI and the payback, and that really helped fuel everything else after it. So 20 years ago, some of these platforms were very costly, cost-effective to put it, not cost-effective to put in, and you know, it's a multi-year project with you're waiting a couple of years to see the return. So that is part of what's different with this Industry 4.0. And then also I'll mention that the smart sensors that Jim referred to really allow you to start very small with a few photo eyes on a manufacturing line. You can get things like OEE and get your real OEE, which is one of the things that people don't really have good insight into, or even a vibration sensor. A wireless vibration sensor can provide condition-based monitoring on some of your more critical assets that maybe you don't have spare parts sitting around for. All right, we have, we'll go another question here. Do you see a reduction in labor cost in all of the projects you do? And if so, what type of labor? Additionally, how do you see the needed skill sets at the plant floor level changing with the adoption of new technology? Jim, do you want to start on this one and then I'll take it from there?
Sure. So yeah, basically what an MOM solution does is now allow your plant personnel to be more efficient. So basically you eliminate those repetitive tasks, the using spreadsheets and reconfiguring, manually configuring reports and printing reports and all that. You automate so that those repetitive tasks are done automatically, and your personnel can focus on the value added things that they can do, the things that require a little bit more insight into troubleshooting and figuring out where their bottlenecks are and what they can do to improve the system.
Yeah, perfectly. So I'll add to that. In addition, in terms of the skill sets, we are seeing, because of the Industry 4.0 solutions, a lot of the repetitive tasks are being eliminated or reduced, but you still need folks with higher skill sets, even though it may be fewer folks. There'll be higher skill sets, higher paying jobs to be able to basically to handle a lot of the technology and interface with it. So Jim provided some examples, but in addition to that, there's things like, you know, there's mobile robot solutions. So instead of moving pallets around from point A and point B and doing it over and over again, there's now solutions that allow you to automate that. All right, we're at 2:49. All right, we'll do one more question. Where do you create the dashboard, local servers, or inside a customer facility, or do you use services such as AWS? So the answer is both. For MOM solutions within a factory, you can, most of them we can do within the factory on a virtual machine, as Brandon mentioned, or on an existing server on site. But we've also done cloud-based solutions like AWS, where we're looking at disparate assets throughout the country, as an example. All right, let's do one more. Have you had any experience with the reliability of wireless radio frequency systems to transmit and receive between systems? Looking at this from a potential for 2-mile transmission distance. Jim or Brandon, you guys want to comment on that one?
Sure, I'll jump in. So yeah, definitely 2 miles is going to use obviously different frequencies and technologies than a short range Wi-Fi, but there are systems that are designed to go those distances, at least line of sight, as long as you don't have you know, a mountain in between or something like that. And they generally use the lower frequencies, like in the US, they would use the 900 megahertz frequencies. And they have built-in error checking and encryption and those types of things. So there's definitely you know, standards that were developed for that type of application.
Perfect. All right, one last question, and this is a good one. Have you had experience capturing tribal knowledge from an operator-managed machine by capturing data, using that information to create a machine recipe that can reduce the dependency on the operator? Absolutely. So one of the things of digital workflow is exactly that. So instead of relying on your operator who does your golden batch, maybe on first shift, and then once the second and third shift operator pop in, you know, it doesn't run as well, or somebody has sort of an art in terms of how they run it. You want to capture what is the best practice, and things like digital workflow and some of the other functionality within Industry 4.0 or the MOM solution allows you to do that. The example Brandon provided on the silo monitoring, that was one of the key things. The customer had one person who knew how to do the unload sequence, but when that person wasn't there, they were very concerned about everybody else being able to follow the same order or the same workflow. So yes, that's one of the things that workflow does for you, is able to remove that dependency. And not only that, but really combine what are the best practices across everybody who does that function, and then put it into a workflow so that everybody can use that best practice and do continuous improvement. So as they think of better ways of doing it, they're providing suggestions to the workflow, and then the workflow is being changed and then rolled out to everybody that's out there. Okay, that may be all the questions we have time for. Please submit your feedback and any other comments using the Q&A function provided. As a follow-up, we're going to send an email in the next couple of days. So it's going to include the following: answers to any of the questions we did not get to today, a link to the recording of this webinar, a post-webinar survey. Please fill out the survey. We always value feedback and your thoughts. And a registration link for our next webinar, which will be a deeper dive into case study number 1 that we presented today. The manufacturer, Milo's Tea, will be presenting with us their detailed case study. Thank you all for attending, and hope everyone has a great rest of your day.